Okay, so we're going to discuss what is known as a triangle similarity. So we spent the last module talking about congruency and determining the different parts of a triangle needed to determine whether the two triangles were congruency. Now, the last congruency theorem that we talked about was the side, side, side. All right. But what happens if, for example, we knew that three angles in a triangle were congruent? Okay, so for example, let's say that we had a triangle A, B, C, and it had angle measure, the respective angle measures, right? Angle A had some measurement, B had another measurement, and what if I had another angle with the same, another triangle with the same angle measurements? So as it turns out, if we only knew that the angles were congruent, that is actually not enough information to tell us that two triangles may be congruent, right? In fact, they cannot be, right? In fact, what we might have is, let's say, a triangle that is maybe written like this. Right now, here the drawing is not to scale, but if we had a drawing here where these sides of the triangle, so BC would be parallel to, here, let me label these, D, E, F. All right, BC, side BC would be parallel to side EF here. All right, and AB parallel to DE, etc. Right? As it turns out, what these two triangles will have in common is that these would have angle F would have the same measurement as angle C, angle A would have the same measurement as angle D, and angle B would have the same measurement as angle B. So we can see that we do not have two triangles that are congruent, right? Because their sides will not be of the same length. But there is another type of relationship that they have, which is not as strong as congruency, right? Because congruent let me know that each corresponding part was going to be equal, and that included the sides, right? So here we only have a case where the angles are equal, right? So if we have corresponding angles are equal, we have a different kind of relationship. They're not congruent, but what we can say is that A, B, C is similar to triangle right? So we use this little squiggly line here, similar to triangle DEF. Okay, so that little squiggly line is excuse me. Okay, so the little tilde we use to establish the relationship of similarity, right? So triangle ABC is similar to triangle DEF. Okay, and when we say it's similar, what we're referring to is that all their angles are of equal measure, right? And in fact, in order to establish similarity, so here's our theorem to establish that. So theorem AA. Okay, so that states that two triangles are similar. Are similar if two angles of one of one triangle of one equal two angles of the other. Okay. And notice here the stipulation, we only need 2 because we know that the total angle measurement in a triangle is 180. So if you know 2, then the third angle will follow that. They'll have to be the same measurement. Okay, hence that you only need the bare minimum conditions needed are 2 angles need to be congruent or the same measure. All right. Now, as we can see, the sides, if we look at this, these 2 triangles here, right? We notice that while their angle measures are the same, their sides, they're not the same length, right? They're not congruent, the corresponding sides. But there is another relationship that these 2 sides have, right? So here, let's establish that now here. So here, right? So while their sides are not congruent, they do have a relationship here. And the relationship that we have is that the ratio of the corresponding sides. So theorem. So this is another theorem or just a property of these similar triangles. Right, so given two similar triangles, and let's use the diagram we have up here, right? Triangle ABC, similar to triangle DEF. Then we have corresponding corresponding sides are proportional. Okay, so corresponding sides are proportional. So what that means is, let me zoom out here. So, come on. Okay, so, okay, here. Okay, so looking at these 2 triangles here, right? The corresponding sides AB and DE, those are in the same proportion. Over DE, right? As the other corresponding sides, right? So AB over DE. And then the other proportion, right, would be BC over EF. And then the third one here, AC over DF. All right, and as always, the order that you write this similarity statement is important, right? this gives me the corresponding sides, right? AB, DE, BC, EF, etc. Right? So that's how the sides are related. They're not congruent, but the ratio of the corresponding sides is equal to the other ratio of the corresponding sides. Okay? All right. And as always, for these proportions, the reciprocal also gives me a true statement, right? In general, any proportion, if you take the reciprocal, so what also would be true, DE over AB to EF over BC, DF over AC. All right. Okay, and that is what similar triangles are.